Hello and welcome to this tutorial video. My name is Karen De Leener and I'm working as a cardiovascular market specialist at Materialise headquarters in Belgium. In this video I will explain how you can use the Mimics Innovation Suite to analyze the tricuspid valve. The tricuspid valve is located on the right side of the heart, between the right atrium and ventricle. The most common disorder of this valve is tricuspid regurgitation, in which the valve does not completely closes when the ventricle contracts. This allows blood to flow backwards from the right ventricle to the atrium, which can lead to a higher blood pressure and even heart failure. The standard treatment is open heart surgery, which comes along with multiple risks. As an alternative, transcatheter-based solutions are rapidly gaining interest. With this technique, a replacement or repair device is inserted via the inferior or superior vena cava and positioned at the tricuspid valve. Currently, there is a variety of these transcatheter replacement and repair devices being developed. The Mimics Innovation Suite can be used in different phases of this development process, from R&D to get an understanding of the complex anatomy of the target population, to first screening and planning, and finally to scale up through scripting for larger clinical trials and the commercial launch. Since the tricuspid valve is a complex structure and given the variety of devices being developed, I will explain multiple key measurements. First of all, we'll analyze the tricuspid annulus, then the right atrium and ventricle, and finally the inferior and superior vena cava. Let's switch to the Mimics Innovation Suite. The segmentation of the heart has already been performed by using the CT heart tool as explained in other tutorial videos. We'll hide the parts that are not of interest at this point. To analyze the tricuspid annulus, we'll first indicate the annulus by drawing a spline. For that, we'll go to the Analyze menu and select the Spline tool. I will make the indications on the 3D model, but you could also do the same on the images. Double-click at the last point to close the spline. Then you can edit your contour both on the 3D model by rotating around and dragging your control points, or on the images.
Then you can immediately make any measurements between any points on the spline. Make sure the snap options are toggled on. You hide everything except for the spline. Go to the measure menu and select the distance tool, and then click between any of the interested points on the spline. We will now look at another option to analyze the tricuspid annulus. So let's hide the previous measurements and show the right ventricle. Then we will create a best fit plane to this spline and reslice the images along this plane. Then we will go to the Measure menu to create an area measurement. For some tricuspid replacement and repair devices, a quantification of the right atrium and ventricle is needed. After a segmentation, the volumes of the different structures can immediately be obtained from the Properties tab. This could be done in both systole and diastole to get an understanding of the minimum and maximum dimensions. Other measurements, such as distances, could be performed depending on your needs. Let's, for example, take a measurement from the tricuspid valve through the apex of the right ventricle. Most of the transcatheter tricuspid devices will enter the heart by the inferior or superior vena cava. Some devices will even consist of a stand graft or anchoring mechanism in these vena cava. Hence, a proper understanding of these structures is required. We'll start with creating a centerline of the vena cava for an accurate analysis. Let's use the superior one as an example. To create a centerline, you need a tubular structure. Hence, we will cut off the rest of the right atrium and then fit a centerline to the superior vena cava. Toggle on the transparency to see the centerline. Based on this centerline, multiple measurements can be performed. For example, the best fit diameter and the sectional area. These measurements are made at every location perpendicular to the centerline. Also, the length along the centerline, the curvature, and other measurements can be performed. Another important measurement is the angle between the tricuspid valve and the vena cava. This angle is key to ensure that your catheter can reach the tricuspid valve. Let's use the inferior vena cava this time. This was a tutorial video on how to analyze the tricuspid valve with the Mimics Innovation Suite. I hope this gave you a good insight into some of the key measurements that are critical to understand your target population and develop a realistic prototype. Also later on, during clinical trials or your commercial launch, these measurements are key to screen the correct patients and perform proper pre-procedural planning. Feel free to visit our website and get in contact for more information. Thanks for watching and take care.